So we're basically going to be looking at electric charges today.
Mm-hmm.
Now, we know that things can either be charges, can either be positive or negative.
Mm-hmm.
And we found that if it's basically, they'll exert forces on each other. And if we've got positive and positive, then they will repel. So that means the force will push them away from each other. If it's negative and negative, then it will again push them away from each other. And if it's positive and negative, then we find that they attract. And if it's negative, negative, they repel. And if it's positive, positive, they repel as well. Okay. So these electric charges exert a force, and this is called the electrostatic force. And this electrostatic force is exerted over a distance. So when we were doing forces earlier, we talked about different types of forces, and this is one of the type of forces, and it's considered a non-contact force because the particles do not need to be together to feel this force.
Mm-hmm.
Now, how does an object become charged? Well,
The amount of electrons.
yeah. We discussed before that an objects are made up of atoms, simplistically, and basically by losing or gaining electrons, then it will lose, remember, electrons are negatively charged. The object will become positively, or negatively, if it gains it, charged. And that's our basic idea. Your object is made up of protons, neutrons, and electrons. It starts off at an equal number. Because you've lost electrons, then you've now got more protons, so it's positive overall. If you've gained more electrons, you've got more electrons than protons, and this time it's negative overall. And those are things we talked about before. We also talked about how you've got conductors, insulators, and semiconductors, how they're different based on resistivity. We also briefly explained why metals can sort of conduct electricity and why, based on their structure. And then we basically also introduced Coulomb's law, which we said was useful for determining the magnitude of the electrostatic force. And we told you that the force, the electrostatic force, was equal to kq1, q2 over d squared, where k is Coulomb's constant, so it's 9 times 10 to the 9. Q1 is the charge on particle 1 in coulombs. Q2 is the charge on particle 2, also in coulombs. And d is the distance between the particles. Measured in meters. Okay. So here's the thing. We want to be discussing if this force is a non-contact force, what we'll be talking more about is how can charges exert a force over a distance?